Nice intro for another binomial theorem example. Okay, again, here is our Pascal triangle that I've written for our convenience so I don't have to duplicate it. And we're going to take this binomial now, and it's a little bit more complex than the other two examples we did. We have a positive 2x, and then we have a negative 2y in our terms. And we're going to raise this binomial to the fourth power. So we need to locate the fourth row in our Pascal's triangle. So let's go ahead and locate the fourth row, and here it is right here. Our wonderful fourth row. We're going to write down those numbers with nice large space in between them so that we won't be sloppy and we'll be able to write everything in. And just as in our first two examples, we're going to take this first term, which is now not just a variable, but it's a complex term. It's 2x. And we're going to write it down next to our coefficients that I just wrote out. Let's see. One more to write, and then we're going to take our second term, which is a negative. Don't forget that negative 2y, and we're going to write that in parentheses next to all those x terms I just wrote. Okay, our next step is then to put our plus signs in between all of our terms. So we should have our plus signs in here. Our last step before we go and simplify is to add our exponents. And if anybody can remember, when we start adding exponents to our first term, we start with the highest exponent. And here, since this was being raised to the fourth power, we start at 4 and we count down 3 and 2, 1 and 0. And for our second term, we always start at 0 and count up. 0, 1, 2, 3, and 4. All right, so from the last lesson, you should have realized by now that anything raised to the 0 power is 1, so we're just going to go ahead and cross those off so we don't have to deal with them. But now let's go ahead and raise 2x to the fourth power, and again we have to raise everything in parentheses to the fourth power, including the number. So 2 to the fourth power is going to be 16. And x to the fourth power is x to the fourth. So we only have two numbers, which makes this really easy to multiply. We get a 16x to the fourth. Now this term right here is going to be a little bit more complicated because we have two things to raise to powers, and then we're going to have three numbers to multiply. So let's raise 2x to the third power, and that includes raising this 2 to the third power. 2 cubed is going to be 8. And then that's going to be x cubed. And then to the first power, negative 2y to the first power is just a negative 2y. So we're multiplying all these together, so we have these three numbers to multiply first. So let's go ahead and multiply 4 times a negative 2. That gives us a negative 8. And then we're going to multiply that by 8. That gives us a negative 64. So our coefficient for our second term is a negative 64, and then our variables are just going to be x cubed and y. Now for our third term, again we're going to have three numbers to multiply this. Let's go ahead and square 2x. So 2 squared is 4 and x squared is x squared. Let's go ahead and square negative 2y. Negative 2 times negative 2 is 4, and then y squared. We have these three numbers to multiply. So 6 times 4 is 24. 24 times 4 is 96. And then our variables will be x squared and y squared. Two more terms left. So 2x to the first power is just 2x. Negative 2y cubed is going to be a negative 8y cubed. So we have three numbers to multiply. 4 times 2 is 8. 8 times negative 8 is going to be a negative 64. We're going to have our variables of x and y cubed. And the very last term is negative 2y raised to the 4th power. This will give us a positive 16y to the 4th power. And we're going to multiply that by 1, so that's the easiest one. 16 to the 4th power. So if you had done this long multiplication, multiplied this out the long way, 2x minus 2y multiplied by itself 4 times, you would have gotten this polynomial right here. There's your answer.